Okay, let's start with this one. And the reason that I want to do that is this is about as simple as you can get, as you can see. Now, and one thing I want to mention, like I said, a lot of these come from the 03's website, and that's www.bug-transmitter.com, and go there and check him out. But what I want to show you is this. Now, when we were studying, and I got a video, I'll link it in the description, on how a transistor basically works. We had several things we looked at. We have the transistor, and we're going to be using NPNs. Now, in that little thing that I did about the where it was adding an amp to the crystal transmitter, we noticed that we had several things. We had a bias resistor, and we had a load resistor. Now, before, the load resistor was where this capacitor is, and we had a self-biasing resistor that came off of here and then came down into here where it connects into the base of the transistor. Now, on this thing, and we'll see a similarity, our bias is in a fixed bias setup, and our load resistor is coming off the emitter instead of the collector. And the ratios, look at the ratios. Remember, we were before, because we were trying to get half of what the supply voltage is, we kind of set the ratios of the bias and the load resistor so we would get that. We have a different deal here. Now we'll see that some of them you're close to that ratio, but it doesn't seem to be that big of a deal. Okay, so we got a 4K7 here, and we still have the smaller load, which is 330 ohms. Now, keep that in mind, and we're going to look at a couple more, and then we're going to talk about this a bit because it's kind of important. Okay, now, like I said, here's another one from Darren at the 03, and they're www.bug-transmitter.com. So just kind of remember that, because like I said, I'm not making this about his, but because his stuff is shows it so well, I like using it to describe this. Okay, here's another one. Same deal. Our coil is up here off the collector, as is the antenna. Over here is our bias resistor, and it's in a fixed bias position. And here is our load at 100 ohms. Up here we got 47K. Pretty much same ratio for this one. And once again, we have a coil now on here. He's got 5 turns, 3 millimeter diameter, 0.5 wire, and that changes too. And look here, we only have one capacitor at 33 picofarads, and you'll see some that'll have 2. So that varies a lot too. And another thing you're going to find, the voltages are going to vary. So we got a pretty wide range to work with. And this one here is another simple one, but and I'm going to show you in the next diagram. You can add on and on and on, but this is the basic thing that we want. If we can get this to work, we can get the rest of it to work. What we want to do is we want to have this oscillate, and so it oscillates so this tank circuit can go back and forth at the frequency we want, and then this will keep it going and pump it out to the antenna. All right, so now we're getting a little more complex, aren't we? What's interesting about this, once again, if you go back and study our amplifier transistor video, you will see this is pretty much the setup we were using right here. This has this self-biasing resistor, self-biasing setup. The load resistor is up here off the collector, and look at the ratio, 10K to 1 meg. That's kind of the same ratio that we was using, 100 to 1. So this is now, we're seeing something familiar. And why is that? Because this is the amplifier. This is not oscillating the circuit. Now let's go to the oscillator. Once again, the oscillator, the only thing on the collector is our tank circuit. And here, look, 33 pico and 33 pico, and they're in parallel. So you've got what, 66 pico right there, along with a 4-turn coil. So that right there, that's double what we've seen before. What's going on there? It just goes to show that you can really play with these values. But yet, look, on the emitter, we have our load resistor, and we have the bias resistor in a fixed bias position coming down to the base. So even though this is more complex, it's still the same deal, and you got to keep that in mind. So although it's the same setup, there's different values, and that's important to remember too. Okay, here's one more that I want to show you, and look how complex this looks, but really it's not. First of all, look at the voltage difference. It goes from 1.5 all the way up to 12. And you're going to be able to do that with yours too. You're going to have a wide range there. Now what's going on here? Here's something a little bit different. Which one is the, where's the oscillator at? Well, I would say, coming back to here, this one is the oscillator. If you notice, we have now we have an adjustable capacitor along with our coil. Plus, we still have a 33 pico. That 33 pico comes in quite a lot. We have a stabilizing 10 picofarad cap between the collector and the emitter. We have a bias resistor set in the fixed bias position with a load resistor set down here off the emitter. So I would say that that is our oscillator. Now this one's set up, so now you're taking the signal that has the wave and everything all ready to go, and this is cranking it up even more here. So we don't have to worry about this. We have to worry about back here. The main thing I want to show you is that even though it's more complex, we still have the basics right here. And we're going to go with what Rick told us a while back. He goes, you know, you can use other people's stuff, and then you can start changing your values and see what happens. You know, that's, you know, we're not being paid to do this. We shouldn't be on any kind of a time schedule. We should be able to do this in our leisure and, you know, take our time and do it. And, take notes. Look at what's going on, and so you can refer back. Because if you're anything like me, geez, I hope not for your sake, but I can't remember all this stuff, so I have to take notes, and I have to have things I can reference. Now, and I hope this shows up okay, and if it doesn't, we're going to draw it out here on the whiteboard anyway. But this is the design that I came up with, the one I'm showing you right now. And there's some extra stuff. I've got an indicator LED over here. This looks like it's coming off this way, but actually this is my stabilizing capacitor that runs from the hot side to the ground side on my rails. But when we look here at our basics, I have a resistor in the fixed position here. I have a load resistor coming off the emitter, and my coil and my capacitor is coming off of the collector. And that's from what I've taken from all the other transmitters that I've built and worked on, that's why I use that setup here. So now what I want to do, and I'll give you a better view of this, and when we're done you can copy that, you can make your own, whatever you want to do. Well, we want to get you into a working transmitter for sure. All right, I've got a small drawing here, and I thought we would kind of follow what we were looking at in the schematics. So we'd kind of maybe fill this in a little bit here. All right, so we have our schematic, and just from what we was looking at in the other schematics, we're going to try to figure out what we can put in here, and remember, this can be changed depending on what we have. We might say, well, you know what, I don't have this, let's test something else. And if you have a decade box, sometimes that helps things too. Now for T1, put this up here, for T1, I'm going to put a 2N2222. But you can use, do an A. You can use a 3904. Anyway, almost any NPN will actually work in there. So let's go with that for right now. Now on the circuit that I just built, and I talk about having something just on hand. For my resistor here, which is the fixed bias resistor, I used a 39K, because I had it, I put it in, it worked, and I kind of went with it. But I was thinking about us going with the maybe doing something like, let's see, if we would go with 1K on the load, then times that to 100, and let's go 100K. So let's, just for kicks, let's go 100K here. Okay, 100K here, and then we're going to go 10K down here. All right, 10K down here. Now, and I can go back over this and make this more neat. But that's our 100 to, is that right? 1,000. Yeah, that'd be right. Okay. So let's go with that. Now, this resistor here, which it's kind of like a stabilizer, but it's good if you want to hook a microphone up. That's why I put the dotted lines on there. If you run a connection from your input here, run it into the positive on the mic, and then run that to your ground rail, you can put a microphone in there and kind of use it for a like a spy bug or whatever. I mean, I don't do that stuff, but it's there. And this would be a 10K here. Okay. Now, let's say this here, and this is one that you'll see in a lot of them. We're just going to go with a 1 microfarad capacitor. This is your positive, this is your negative. And then our cap right here, which is like another stabilizer. Let's go small. 0.001 up there. Okay. Now these these are all usually pretty much easy to find. So so far we're doing pretty good. Now let's start looking at our area here. We've got our tank circuit up here. Most of the time you always see these are going to be this is going to be a 10 picofarad, and usually your stabilizer between the your emitter and your collector is usually around 10 picofarads too. Okay. Now if we decide if we want to use, I didn't put this in here, let's put a little capacitor going out, and let's put that one at 22 picofarads, and you can play with that. You can play with that. So that's not that big of a deal. All right, we want to have an LED for, so we know the thing's on, right? I think I used 100K on that. Is that right? And put it down. I think I did though. I used a pretty high one. Well, let me look. Let's go with 100K for right now. We might change that. Okay. And then our capacitor to stabilize the two rails, we're going to go with a 0.1 farad. Now these are, when you look at all these and you go back and look through the different schematics we looked at, these will all fit in, and usually these values will get your circuit oscillating. Now, normally, if you noticed, a lot of them on the coil, they had like 4 turns around, an item, or they had 6 turns. What we're going to do is we're going to use a 1/4 inch 20 thread bolt. So it's a 1/4 20 bolt, and that's the coarse threads. The 1/4 20 is the coarse threads. And instead of 4 or 5 or 6, we're going to wrap it 8 times, and I'll tell you why. That gives us a wider range because we're not going to use a ferrite rod in here. We're going to actually use the bolt itself. So we can really dial it in and bring it out. It gives us a wider range. So 8, even though it's more turns, we can crank that in and adjust it the way we want. So we're going to put up here 8 turns. 8 turns on a quarter, whoops, 20. Okay? As we build it, and once we get it going, and you'll see when we crank it in and we crank it out, you can change the channels. You know, now on the one that I just did, because I wanted it to be really stable, and I haven't mounted it in a box yet, I put hot glue on it so it would stay at one position. But I'm thinking later on, if we wanted to, we could actually put this in a box and have that screw sticking out like an adjustment, and so that would be like our tuner. Because remember, we're not going to be squeezing or spreading the coils. We're going to turn this bolt in and out to get our frequencies. So now this is a real basic deal, okay? Okay, we got 10K here. We got 1 microfarad here, and this is our input. Okay, inputs here. This is our coupling capacitor to come in. Comes into our base, and then we also have this right here. We have a fixed bias. Remember now, because this is not like the amp that we were looking at before. This is a fixed bias, and we're going to use a 100K up here, and this is our load, and we're going to use a 10K down here. Now let's say you just have a 1K. Well, if you have a 1K, then drop the 0 here, then drop the 0 here. So instead of a 100K, use a 10K up there, and that's a good starting point. If for some reason it's not working right, play with those values a little bit. Usually though, like I said, with this setup here, if you have that stabilized with 10 picofarads, and then you have your tank circuit with 10 picofarads and an adjustable coil, and if we didn't have the bolt, we can always squeeze it and spread it, but the whole purpose is to keep the coil in good condition and bring the bolt in and out. So that will usually get it firing. Plus you have you're coupled to the antenna with this 22, and that's common. If you look at those other ones, go back and look at, you'll see that's a common value. Sometimes you'll see 33. But, either way, and you can play with that too, but that should be good. And then we've got 100K here for our LED. But if we need to change it, when we put this on the breadboard, we'll play with it and we'll see if that works, and if not, we'll find one that does, because we're gonna build this together. And then this is a stabilizer here. This kind of keeps everything in check. This keeps your values. You don't have stray DC. It's a steady thing. And we're going to use 0.1 microfarads there. So that ought to do this for now. See if you can gather up your parts. And like I said, 2N 2222A, or just a 2222, a 3904 will work. And then there's some, and I can't think of all the other ones right now because I don't have a memory anymore. But most of your common NPN transistors will work here. So don't worry about that. And I'll pop a couple in. We'll do a couple of them to check that out. But hopefully you have a breadboard. If you don't, in our hobby, it's something that's really nice to have, and they're pretty cheap. And if you don't have the wiring kit, you can get some wire in you can make your own wires, your own connecting wires, but they're really nice to have. And the one thing we got to remember, and we'll go over this when we start actually putting the parts on, is for this to work even close, because breadboards, how many times you've heard that they have a lot of captants in them, and so the closer you have all your components on the board, the better it works. And we're going to talk about that, just like we might talk about the difference between inductance and resistance in the coil too, because that's something good to know. So okay, this has been long enough. I wanted you to kind of see where we're going, see if we can collect some parts, and in the next video I think we'll go on to the onto the bench itself, and we will start putting our stuff together on our breadboard. Until then, everybody have a fantastic day, and I'll talk to you later. Bye.